So the malonic ester synthesis is a very convenient way of making substituted carboxylic acids. So we're starting out with malonic ester, this piece right here. And the first thing we're going to do is the deprotonation. So we're going to treat it with the alkoxide, and that's going to deprotonate the carbon between the two esters, right? We'll remove a hydrogen from that. We're going to do alkylation at that site, and in this case we'll use ethyl bromide. The hydroxide is going to hydrolyze both esters to the carboxylate. And if I treat it with acid, I'm going to wind up with the dicarboxylic acid. Dicarboxylic acids, especially alpha carboxylic acids, are prone to decarboxylation reactions. So one of those carboxylic acids is going to decompose, and what I'm going to wind up with is a single carboxylic acid with my ethyl group on it. So we've lost it. And we'll go through each step of the synthesis. So this is a single alkylation reaction. We're doing one alkylation. The next sequence shown is a double alkylation reaction. So the first one is going to be the same. We're going to do the ethylation, and then we're going to treat it with base again, and we're going to do a methylation with methyl iodide. We're going to hydrolyze and heat it up to do the decarboxylation, and the product is going to look like this. So we'll have our acetic acid, the ethyl group that is on here, and then in red I'll just draw the methyl group that's going to be attached to it. So it's a good way of making substituted carboxylic acid. So essentially this piece, right, that carboxylic acid is getting alkylated at this position, in this case once, forming this bond, and in this case twice, forming that bond and that bond in the reaction. So let's work through the sequence. We'll go through the double alkylation product on the next slide. All right, so starting out with malonic ester, we're going to treat this with the alkoxide base, which is going to remove that hydrogen between the two. This is a very acidic hydrogen, and we'll put those electrons right on that carbon. Now I can show the resonance structures where I could show it stabilized throughout the two carbonyls, but I'm not going to do that in this case just for brevity of the video. All right, the next step, we're going to do the alkylation of this. We're going to use the ethyl bromide for that alkylation. So I get SN2 displacement of this, and what we wind up with is the single alkylated product. I still have a hydrogen on here. I'm going to deprotonate that again without ethoxide to generate another anion. And that's going to look like this. Okay, and that's going to do another SN2 displacement of the methyl group. Kick out the iodide, and we are going to wind up with the dialkylated material. Which is going to look like this. The next step, we're going to do the hydrolysis. So if I treat this with hydroxide, hydroxide is going to add to both of the carbonyls and kick out the ethoxide. So it's going to happen twice, addition and elimination. I'll do the same thing, hydroxide on this side. We're going to wind up with an intermediate that looks like this. And again, this may happen in two steps. I'm drawing it as if both are happening at the same time. So again, this will be the methyl group and the ethyl group that are attached. Now we're going to kick out the ethoxides. That's going to give the diacid. Methyl and the ethyl group. And I'm also going to have 2O-. And that's going to take off the hydrogens from each one of these. And that's going to give me the dicarboxylate. Which is going to be the dianion here. And methyl and ethyl. Treatment with acid gives the dicarboxylic acid, which is going to look something like this. And this one I'm going to redraw to show the decarboxylation better. And this is going to do the decarboxylation when it heats. I'm going to wind up with initially, it's going to look like this. So I have the enol form of the carboxylic acid, and then protonation at this alpha carbon, followed by deprotonation. Let's just draw it stepwise. Followed by deprotonation with water. Is going to go right to, let's go this way, right under here, to give me the carboxylic acid with the methyl group attached and ethyl group attached. So this is our final material for this. So there are a lot of steps. What we need to do, we need to look at a carboxylic acid. All right. And actually, let me change this. Make it a little simpler. Okay. So I need to look at this, and I need to see the acetic acid in it. I need to see this piece and this piece with the carboxylic acid. And these groups are going to be put on via alkylation steps. Okay. So starting with the ethyl acetoacetate, after my deprotonation and the second step, which will be the alkylation, I'll do this one first. All right, we'll use that bromide. What I'm going to wind up with is the initial alkylated product. Then I'm going to deprotonate again in step 3, and then in step 4, I'm going to put in the 3-carbon piece, which will be that. And my product is going to look like this. And then after hydrolysis, which is step 5, and step 6, which is the acid and decarboxylation, I wind up with a carboxylic acid that has those 2 alkyl groups attached to it. just like that.